We're going to start by calculating the volume of a prism with a square base. So this square has a side length of 3 inches, which means that its area is going to be 9 inches squared. Now if we want to think about this square in 3 dimensions, we're going to look at it from the side, and we're going to give it some height. So this still is going to be 3 by 3, but we're going to use the base unit, which is just 1. So this square is like now a block, and it is going to have an area of 9 inches squared, but its volume is going to be 9 inches cubed, because now we're in the 3 dimensions. So if we're trying to calculate the volume of a prism, you can think about a prism as mini blocks stacked on each other. So this block is a 3 by 3 by 1, which means it has a volume of 9 inches cubed. And then we're going to put another block underneath it. This one also has a volume of 9 inches cubed. And then another one, and another one, and another one. So each of these is going to be 9. And if you look over here, if this was 1 inch, now it's 2, 3, 4, 5 inches. So we're stacking 9 5 times. In other words, the volume of this entire thing is going to be 9 5 times. So 9 times 5 inches cubed, which in this case is 40. Oops, my bad, 45. So notice how we calculated the area, which in this case is 9, and we multiplied it by the height, which is 5. So that means that the volume in general of any prism is just the area times the height. And that's where we get that formula from. So now we want to find the volume of a cylinder. This cylinder has a base that's a circle. So we know, for instance, that its height is 10 feet. It's a big cylinder. And we know that the base has a radius of, let's say, 4 feet. Not square, just feet. So that means that the base of this circle has a radius of 4 feet. This base right here is redrawn. So the area of a circle is pi times the radius squared. In this case, the radius, remember from our circle packet, the radius is from the center to the outside of the circle. The radius is half the size of the diameter, which goes from the center, the outside to the center to the outside again. So we're going to be focusing on the radius here, which is represented in the formula for area. So the radius of the circle is 4, so then the area is going to be pi times 4 squared, which in this case is 16 pi. So feet squared, because we're still in the 2nd dimension, because we're talking about the area of this circle here. Now to find what the volume is, we have this circle 10 times. So if I can draw them out, so if this was 16 pi, then this is 16 pi, 16 pi, so on and so forth. Oops, you can't see that. 16 pi, this one would be 16 pi. Basically, each of these discs is going to have a volume of 16 pi feet cubed. So that's 10 times, so that's 16 times 10. Using our formula, area times height, it's just going to be 16 multiplied by 10, which is the height of this, so 160 feet cubed. And the feet get cubed because now we're in the third dimension. Now we're going to find the volume of a triangular prism. So all prisms and cylinders have the formula for their volume being V equals the area of the base times the height of the prism or cylinder. In this case, 6 is the height. And then the area we have to calculate. So the base of this prism is a triangle. And this triangle has its own height of 2 inches, as represented right here, and it has a base of 3 inches. Now remember that the area of a triangle is base times height divided by 2, so in this case 3 is the base here, times height, which is 2, divided by 2. When I'm talking about base and height, I'm talking about the base and height like in this triangle, not the prism. So the base of this triangle is 3, and then the height is 2. So 3 gets multiplied to 2, and then it gets divided by 2 again, so that's 6 over 2, which is just 3 inches squared. So the area is 3 inches squared. So the area is 3 inches squared. That gets multiplied to the height, which is 6. And then you get that the volume here is 18 inches cubed. The volume of pyramids and cones is relatively straightforward if you know what the volumes of their counterpart prisms are. If you know what the area is of the base, and you know what the height is, then the volume is just like that of its counterpart prism, but just divided by 3. So in this case, this would be the area of a circle, which would be pi r squared multiplied to the height divided by 3. So you'd have to calculate the area first, multiply by the height, and then divide by 3. In this case, we have a triangular cone, or a pyramid, which has another name, which is called a tetrahedron. In this case, you would calculate the area of the base here, multiply it to the height, and then divide by 3. It's exactly the same. Any geometric shape that gets tapered off like this is always going to have this formula. Even if it's not a circle or a triangle, it could be any shape. As long as you know what the area is of the base and the height, you can solve for its volume. Like I just covered, the volume of a pyramid and a cone is the area of the base times the height of the cone or pyramid divided by 3. Their counterpart prisms have a very similar formula. It's just the area of the base times the height. So that means that suppose you have 3 cones that are exactly the same. Each has a radius of 3 and a height of 10. If you added the volumes up, it would equal the volume of its counterpart cylinder, which in this case also has a radius of 3 and a height of 10. If you wanted to solve for the actual volume here, you would find the area of the base, which is pi r squared, which in this case is 9 pi, That would get multiplied to the height to find the volume. So that would be 9 times 10, 9 pi times 10, which would be 90 pi. So the volume of this is 90 pi. We'll call it inches. And then over here, the volume is the area, which we already calculated is 9 pi because the bases are the same, times the height, which is 10, and then divided by 3. So in this case would be 90 divided by 3, 90 pi divided by 3, which is 30 pi inches cubed. So this would have a volume of 30 pi. This one, and this one. And then they add up to 90. So now we're going to do an example of a cone. So this cone has a base that's a circle, like all cones do. This circle has a diameter of 12 feet. It has a height of 9 feet. So remember that the volume of a cylinder or the volume of a pyramid or a cone is the area of the base times the height divided by 3. In this case, the area of the base is going to be the area of a circle that has a diameter of 12. Remember that the area of a circle is pi times the radius squared, but this is not the radius, this is the diameter. So to find the radius, I just divide by 2, and then the radius is 6. So the area of this base is going to be pi times 6 squared, which is 36 pi. So now I know what the area is, I know what the height is, and then I just divide by 3. So plugging this in to the formula, the area is 36 pi. That gets multiplied to 9, which is the height, and then divided by 3, which is 108 feet cubed. 108 pi feet cubed, because the pi hangs out. Here we have a pyramid. To find the volume of this pyramid, we're going to use the formula area times height divided by 3. So we'd have to find the area of the base, which in this case the area is of a rectangle that has a length of 5 and a width of 4. So the area would be length times width, which is 4 times 5. So the area would be 20 inches squared. So we know that the area is 20 inches squared. That gets multiplied to the height, which in this case was drawn off the paper, but it is 8 inches. So the height is from here to here, is 8 inches. So 20 gets multiplied to the height, area gets multiplied to the height, and then gets divided by 3. And you would get 160 on top, gets divided by 3. The volume would equal 53.33, etc. inches cubed.